Yesterday I have done some problems in maxima minima, so we'll continue with that now. Okay. See, all of you please take out the textbooks, page number 310. Page number 310. Maths 1B textbook. Solved problem 1 we have yesterday completed. So second one I have written already on the board. Please read it. See, these are examples where we have to try to use the second derivative test to find the local maxima and local minima. So if it fails, then second derivative test. If it fails, then we can use the first derivative test. So what is the question here? Find the points of local extrema. Local extrema means local maxima and local minima both. Okay. Find the points of local extrema of the function f of x is equal to x power 6 for all x belonging to R. Also find its local extrema. So first I ask the students, are you able to hear my voice clearly?
Yes, sir.
Okay, 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 right. Now let us start solving the problem. F of x is equal to x power 6. Is it not? This is the function, and of course this is a 6th degree polynomial. You know the domain is R, and he has given x belonging to R. The entire domain we have to consider now. What is f dash x? F dash x is what? Tell me, sir.
X power 5.
Tanmayi, please tell what is x, f dash x?
Sir, 6x power 5, sir.
Very good. So this we have to equate it to 0 to find the stationary points. Then we'll go get only one value, x is equal to 0. So x is equal to 0 is the only what? Stationary point. Stationary point means derivative is 0. So it has got, the function has got only one stationary point, that is x equal to 0. Now we have to find whether this stationary point is a local maxima or local minima or neither of them. It is possible. Every stationary point need not be local maxima or local minima. So it can be neither of them also. So how do you test? Let us use this, try to use the second derivative test. What is second derivative? Tanmayi, please tell second derivative. For 6x power 5, what is that?
30x power 4, sir.
Yes, correct. 6 into, for x power 5 it is 5x power 4, that is 30x power 4. This second derivative, so value we have to find at what point? At x equal to 0. We have to at x equal to 0, where at the stationary point we have to find the value of the second derivative at x equal to 0. Okay, what f double dash 0? So 30 into 0 power 4, that is 0. So if the second derivative is positive, local minima. Second derivative is negative, local maxima. But second derivative is here 0. So what can we say now? We cannot say anything about the function at x equal to 0 now, because the second derivative test has failed. Second derivative test has failed. We can write second derivative test has failed to give any clue about the nature of the function at x equal to 0. Okay. So then we can better use the first derivative test. What is the first derivative? 6x power 5. I am writing it again. Okay, 6x power 5 is the first derivative. What is the stationary point at x 0? So here I am plotting sine of f dash x. Sine of f dash x. So at 0, of course, first derivative is also 0. What about the sine of the first derivative when x is less than 0 here? That is, x is negative. X is negative means x power 5 is negative or positive? So 6 into x power 5 is negative here. Now after 0, that is when x is positive, what is x power 5? Positive. So 6 power 5, x power 5 is positive. So therefore f dash x is changing sign from negative to positive means decreasing to increasing. Is it not? The function is actually decreasing in the beginning and then it is increasing. Means what? Huh? Local minimum. Correct. So at x equal to 0, local minimum is there. At x equal to 0, f of x has local minimum. Correct. So here the second derivative test has failed. That is why we have used again the first derivative test. At x equal to 0, f of x has local minimum. What is the local minimum value? Local minimum value means that x equal to 0 we have to put in the original function. Local minimum value. Correct. Local minimum value is f of 0, that is 0 power 6, 0. So at x equal to 0, the function has at x equal to 0, the function has local minimum value and the local minimum value is 0. So let us go to the next question. So still people are joining. Next page is blank. Okay, I'll go to the next page. So now this is the next question. Find the points of local extrema and local extrema. Local extrema means local extremum values of the function. Okay. Find the points of local extrema means we have to find the values of x where the function is having either local maximum or local minimum, and the local extrema means the values of the function at those x values. Okay. For the function f of x is equal to cos x. So let us start the solution. So f of x is equal to cos x. Cos 4x, sorry. Shilpita, are you there in the class?
Yes, sir.
Please tell me the derivative of cos 4x, f dash x.
Sir, 4 into minus 4 into sin 4x, sir.
Correct. For cos 4x, the derivative is minus sin 4x, and for 4x, the derivative is 4. Okay. So this we have to equate it to 0. See, x in the interval, x is in the interval 0 to pi by 2. 0 is less than x less than pi by 2. Here sin 4x is there. So multiply by 2, 4. 0 is less than 4x less than what? Multiplying by 4 you will get 2 pi. So 4x takes values from 0 to 2 pi, then sin 4x will be 0 for what values? Sin 4x is equal to 0 implies 4x must be pi. That is the only value, is it not?
Yes, sir.
From 0 to 0 and pi are open. We cannot equate them. So 0 to 2 pi, only one value is pi where sine 4x is 0. So 4x must be pi, implies x is equal to pi by 4. X is equal to pi by 4 is the only stationary point. Okay, is the only stationary point. Here the function may have local maximum or local minimum. So let us use the second derivative. Come on, Shilpita, again tell me the derivative of f dash x. Minus 4 sine 4x. What is the derivative?
Sir, minus 16 cos 4x. Sir.
Correct. Minus 4 into, for sine 4x the derivative is cos 4x into, for 4x the derivative is 4. So it is minus 16 cos 4x. The second derivative's value, Shilpita. So we have to substitute what value of x here in this? Huh? Come on, tell me. Pi by 4, correct. Where the derivative is 0, that value you have to substitute here. So f double dash pi by 4 we have to see. Is it positive or negative? Minus 16 into cos 4 into pi by 4. 4 into pi by 4 is pi. So minus 16 cos pi. What is the value of cos pi, Shilpita? Shilpita. So minus 16 into minus 1. Is it positive or negative?
Positive. Sir.
Positive. Second derivative positive means maximum or minimum?
Maximum. Sir.
Maximum. Sorry. Minimum. Second derivative positive, minimum. Second derivative negative, maximum. Please remember that. Second derivative positive, minimum. Second derivative negative, maximum. So at x equal to pi by 4, at x equal to pi by 4, f of x has a local minimum. Because second derivative is, let us go back and see. Second derivative is positive means local minimum. And the local minimum value is, let us go forward again. F of x is the function, given function is cos 4x. Is it not? So, local minimum value at x equal to pi by 4 is f of pi by 4. So in the original function we have to put x equal to pi by 4. So cos 4 into pi by 4. So cos pi. So it is minus 1. Okay. Minus 1. So that is the minimum value, local minimum value. Okay, textbook also has given correctly. F of pi by 4 is minus 1, that is the local minimum value. Now let us do some problems on applications of maxima minima. Let us go forward. So applications of maxima minima. These are some practical applications of the concepts used in maxima minima. So you have to open the page number 311 and solved problems. Let us try to do them. First problem. Find two positive numbers. Okay. Find two positive numbers whose sum is 15 so that the sum of their squares is minimum. Okay. Let x greater than 0, y greater than positive numbers, yes said, is it not? Two positive numbers. So let x greater than 0, y greater than 0 be the two numbers. Okay. So Madhuri, are you there in the class?
Yes, sir.
Okay. Let x greater than 0, y greater than 0 be the two numbers. Okay, two positive numbers. Whose sum is 15? That means x plus y is equal to 15. Okay. Now, we have to find these numbers x and y so that the sum of their squares is minimum. So let s be the sum of their squares. So let s is equal to x square plus y square. This should be minimum. Okay. But from the first equation x plus y is equal to 15, what is the value of y? 15 minus x. X. That value of y, let us put it here in the equation for x. X square plus y square means 15 minus x whole.
15 minus x whole square.
So that the value of s will be a function of a single variable x. Okay. So this is the equation. Now this should be minimum. Sum of their squares is minimum. That means s should be minimum. S should be minimum. So what we have to do? Find the derivative of s with respect to. So you can expand it and do it, or directly you can do it. Suppose you expand it, what happens? X square plus 15 minus x whole square means 225 minus 30x plus x square. So it is 2x square. Is it not? X square plus x square, 2x square minus 30x plus 225. Now Madhuri, tell me the derivative of s with respect to x. ds by,
Minus 30.
correct, 4x minus 30. For 2x square the derivative is 4x, and for this it is minus 30. What should we do now? It should be equated to 0. So what is the value of x now? X is equal to 30 by 4, that is 15 by 2. X is equal to 15 by 2. Okay. So what is the first derivative? ds by dx, 4x minus 30. Now let us use the second derivative test. So at x equal to 15 by 2, there is a local maximum or local, there may be. See, we cannot say definitely, but at x equal to 15 by 2, because the derivative is 0, there may be a local maximum or local minimum. How to find whether the function is having a local maximum or local minimum? There are two tests. Let us use the second derivative test. What is d square s by dx square? That means, tell me the derivative of 4x minus 30, Madhuri?
4, sir.
4, sir.
4. Is it positive or negative? Positive. Whatever may be x, it is positive. Whether x is 15 by 2, so it is positive. Positive means what? Second derivative positive means local.
Local minimum.
Minimum. Local minimum. So that means at x equal to 15 by 2, because the second derivative is positive, so the function s, that is sum of the squares, has a local minimum value. Okay, that's all. Find the two positive numbers. So x is equal to 15 by 2 we got. And what is the other number? Y? Madhuri? See this equation. X plus y is 15. So x we got 15 by 2. Y also? Y also?
15 by 2, sir.
So that means we have to equally divide the number, whatever it is. Suppose sum of the numbers is given as 20. Then you have to take x is equal to 10, y is equal to 10. Equal division. Then only the sum of the squares will be minimum. Whatever the sum is suppose 100, 50, 50. Sum is 30, we have to take 15, 15. Then only the sum of the squares will be minimum. And the minimum sum of the squares can be obtained by putting this value there. Okay. So S minimum is what? S minimum is x square, that is 15 by 2 whole square, plus y square 15 by 2 whole square. Whatever is this sum, that is the minimum sum of the squares of the two numbers. Okay, let us see the next application. Go forward, that is blank. Next, let us go forward. There is a problem. Please read the problem. Find the maximum area of the rectangle that can be formed with a fixed perimeter 20. 20. So this is the rectangle. Okay, suppose x is the, L is the length, L is the length and B is the breadth of the rectangle. Find the maximum area of the rectangle that can be formed with the fixed perimeter. So what is the perimeter P? If the length is L and breadth is B, what is the perimeter? Prabhas, please tell me. Prabhas cannot trust. Huh? 2 into L plus. Is it not? 2 times length plus 2 times breadth. That is the perimeter. And that perimeter is given in the problem. And that perimeter is fixed also. So we have to equate it to 20. So that dividing by 2 you get L plus B is equal to 10. Now we have to find the maximum area. So let A be the area of the rectangle. What is the formula for A, Prabhas? L into breadth. L into B. So I can write L into B can be written as what from this equation? 10 minus L. So expanding you get 10L minus L square. So I am writing firstly again here, the area is a function of the length L. So area is a function of length L. And area should be maximum. A should be maximum. We have to find length such that A should be maximum. So we have to find the derivative of A with respect to L. Come on, Prabhas, tell me what is dA by dL? Come on. 10 minus 2L. This we have to equate it to what? 0. Then what is the value of L? Sorry. L is 5. L is 5. So, what is the second derivative? D square A by DL square. When L is 5, say because at L equal to 5 the derivative is 0, the function may have a local maximum or local minimum. Whether it is having local maximum or local minimum can be found by the sign of the second derivative, d square a by dl square. What is it? Come on, for 10 minus 2l, what is the derivative? Minus 2. Is it negative or positive? Negative. So second derivative negative means local maximum or local minimum? Maximum, sir. So second derivative negative means local maximum. So at x equal to L equal to 5, the function A, that is the area, has a local maximum value. So what is the maximum value? If L equal to 5, what is B from this equation? L plus B is 10, so L is 5, B is also 5. If L is 5 and B is 5, then what is the name of the rectangle? Square. Square. So the rectangle will have maximum area only when it becomes a square. Length and breadth must be equal if the perimeter is a constant. If the perimeter is a constant, to get the maximum area, the rectangle must become a square. That is what we have found. And the maximum area is what? 5 into 5, 25. Length is 5 and breadth is 5. So therefore it is Prasad. Prasad, please speak. KVKS Prasad. He has raised his hand, so you can speak now. What is your doubt? So maximum area is 25. KVKS Prasad? Huh? Anything? So running out of time already, the message has come. So 10 minutes more. So let us see another problem now. So this is blank. Let us go further. Find the point on the graph y square is equal to x, which is nearest to the point 4, 0. See, y square is equal to x is a parabola. So it will be like this. Y square is equal to x is a parabola like this. And this side I am putting an arrow. Here also arrow means it will go to infinity. So it will not stop there, it will go to infinity. See, the curve y square is equal to x. 0, 0 is satisfying in it? Tell me. Come on, please respond. Somebody. 0, 0 is... So the graph is passing through the origin. Now, can x be negative? Here, negative. Suppose x is minus 10. Y square is minus 10 means y will be imaginary. So x cannot be negative means in the second quadrant and third quadrant where x is negative, the curve does not exist. So I am telling the nature of the curve. Okay. Then it lies only in the, because x must be positive only. Is it not? X must be positive only. Then y square is positive means y will get two values. For example, y square is equal to x. Suppose x is equal to 4. Y square is equal to 4 means y is equal to what? Plus or minus 2. So, plus or minus 2. So, x is equal to 4, y is 2. X is equal to 4, y is minus 2. Like this, for every point above the x-axis, its reflection in the x-axis also will be there in the graph. Because if h comma k satisfies the curve, h comma k you put in the equation, in place of x h, in place of y k. Then h comma minus k also will satisfy the equation, because in place of x I can put h, in place of y I put minus k whole square. K square or minus k whole square, both are same. So hk, if it is there on the curve, h minus k also will be there on the curve. So for hk on the curve, h minus k is the reflection in the x-axis. So the curve is symmetrical about x-axis, passing through origin, and it lies only in the first and fourth quadrants where x is positive. It does not lie in the second and third quadrants where x is negative. So that is the nature of the curve. I will draw the curve again. Okay, redraw the curve. Okay, right. This is y square is equal to x. So only 6 minutes there. That it is showing in the green color above. Remaining meeting time is 6 minutes. Okay, let us see. This is curve y square is equal to x. Origin here. Right. Find the point on the graph y square is equal to x, which is nearest to the point 4 comma 0. So suppose 4 comma 0 is here, A. It is on the x-axis, is it not? 4 comma 0 means it is on the x-axis. Suppose P x comma y is the nearest point to 4 comma 0. That means the distance AP is minimum. Find the point on the graph which is nearest to the point 4 comma 0. Suppose Px comma y is the nearest point to the point 4 comma 0, that is lying on the curve. Okay, this point x comma y is lying on the curve. So because x comma y is lying on the curve, so it will satisfy the equation y square is equal to x. Now the distance AP, PA, the distance PA should be minimum. We have to find the point such that distance PA is minimum. If PA is minimum, then PA square also will be minimum. So PA means the distance between 2 points, root of x1 minus x2 whole square. The square root will come. So to avoid that, if PA is minimum, then PA square is also minimum, because distance is positive and its square is also positive. PA square is also minimum. Let S is equal to PA square. What is PA square? Tell me. For the point 4, 0 on the graph and xy on the graph and 4, 0 on the x-axis, what is the distance whole square? Difference of x coordinates x minus 4 whole plus y minus 0 whole square means y square. But here we can use this point. Because the point x comma y is lying on the graph y square is equal to x. So x comma y satisfy this equation, y square is equal to x, and in place of y square I can put x here. Here I can put x in place of y square. So therefore S can be written as x minus 4 whole square plus x, because y square is equal to x, because the point is lying on the curve. So you can expand it, x square minus 8x plus 16 plus x. So x square minus 7x plus 16. So S is equal to finally s square minus 7x plus 16. What is the derivative? Come on, ds. So this we have to equate it to 0 immediately. So what is the value of x? X is equal to 7 by 2. So 7 by 2 is a stationary point for this function S. So here the function may have a local minimum value or local maximum value. So to find that, we have to find the second derivative. What is the second derivative? D square s by dx is
2, sir.
2. What is the value of second derivative at x equal to 7 by 2? That is also 2 because that is a constant. So it is positive. Second derivative positive means what? Local minimum. Local minimum. Correct. Local minimum. So that means at x equal to 7 by 2, s is minimum. S means the square of the distance. Square of the distance means minimum means the distance is also minimum. So we can find the x is in the equation of the graph C in the above. X is what? 7 by 2. Then y will get two values, is it not? Plus or minus root 7 by 2. Y square is equal to 7 by 2 means so there will be 2 points on the graph. One here in the first quadrant, one here in the fourth quadrant. What are the coordinates of the point in the first quadrant? Nearest point? Root 7 by 2. Sorry, 7 by 2. X value 7 by 2. Okay. X value 7 by 2. Y value root 7 by 2. What is the point in the fourth quadrant? 7 by 2 comma minus root 7. So these are the 2 points on the one in the first quadrant, one in the fourth quadrant. These are the points nearest to the point 4 comma 0. Origin is not nearest. See, origin is not the nearest point, but one point above in the first quadrant, one point below in the fourth quadrant are nearest points to the given point 4 comma 0. So less than 1 minute time is there. So we'll stop here. Tomorrow we'll meet. Okay.
Sir, just a small doubt.
Who is that? Who is that?
Pranav, sir. Pranav.
Pranav, tell me.
Sir, but minus root 7 by 2 is will be an imaginary number, no, sir. How can we...
No, minus root 7 by 2. Minus is outside. Okay.